Hydrocarbon derivatives. A hydrocarbon derivative is formed when there is a substitution of the functional group at one or more of these positions. An almost unlimited number of carbon compounds can be formed by the addition of a functional group to a hydrocarbon. Naming alkanes. I'm going to say the rules to name alkanes. The step number 1 is to count the number of atoms in the longest continuous chain. That is the parent chain of the structure. The step number 2 is to number each carbon in the parent chain. Locate the end carbon closest to the substituent group. Give all the substituent groups to the lowest position numbers possible. The step number 3 is to name each alkyl group substituent. Place the name of the group before the name of the parent chain. The step number 4. If the same alkyl group occurs more than once as a branch on the parent structure, use the prefix D, tri, tetra, or so on before its name to indicate how many times it appears. Then, use the number of the carbon to which each is attached to indicate the position. The step number 5 is when different alkyl groups are attached to the same parent structure, place their names in alphabetical order. Do not consider the prefix D, tri, or so on when determining alphabetical order. And the last step, step number 6. Write the entire name using hyphens to separate numbers from words and commas to separate numbers. I'm going to solve an example about naming alkanes. Here is the example. The step number 1 is to count and find the longest chain. In this case, it's this one that has 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Then the step number 2 is to number each carbon of the parent chain. We have to take into account that we have to name from right to left because here is the first substituent group and this is closest to the substituent group than this one. So this is the longest chain, and then I will number them 1, 2, 3, 4, 5, 6, 7, and 8. Then I will name each alkyl group substituent. In this case, this, as it has 1 carbon attached to the chain, they are methyl. And this one that has 2 carbon atoms is ethyl. Now that we have the name of the substituents, we have to use the prefix. In this case, we are going to use D because there are 2 substituents in the same chain. We are going to use dimethyl. And here we are not going to put anything because it's just one substituent. Then I am going to name the chain, the alkane. Here we have to order it by alphabetical order. And in this case, ethyl, it's going first, then methyl. We don't take into account the D, and it's going to be in the position 1, 2, 3, 4, 4, ethyl, 1, 2, 3, 5, 3, 5, dimethyl, and the name of the chain is octane. And this is the name. It is 4-thiol-3,5-dimethyl-octane. Drawing alkanes. I'm going to tell you how to draw alkanes. Step 1. You have to see the end of the name that it gives you, and with this information you are going to know how many carbons are in the longest chain. Step number 2 is to find and take into account the prefixes like D or tri or tetra, and with them, if there are some, you will know that you have to put 2 or 3 carbon atoms in one substituent. Number 3, you have to see for the position. For each carbon atom, if it says dimethyl, you are 2 dimethyl. You are going to put in the position number 2 the 1 carbon atom. Step number 4 is to arrange all the carbon atoms in the chain and to see how it ends. Here we are going to see an example of drawing alkanes. The example is 4-ethyl-5-isopropyl 2,2 dimethyl nonane. Here we have the name that indicates the number of carbon atoms that are in the longest chain, that are 9 nonane. Since we don't have the positions, first of all I am going to put the carbons for 5, 6, 7, 8, 9. And we are going to start from any side. I'm going to start from right to left. First is ethyl, because it is in alphabetical order. It doesn't matter, but we prefer to do it like this. 4. 1, 2, 3, 4. Ethyl. Ethyl are 2 carbon atoms. So here we have CH, CH2, and CH3. Then isopropyl. Isopropyl means that it has to be in the same row. Isopropyl 5. 1, 2, 3, 4, 5. So here we have CH and CH and CH, CH3, CH3, CH and CH. Then 2,2 dimethyl. Methyl is 1 carbon atom. So 2,2. There will be 1 here and 1 here. So we have 3, 3, 2, 2, 2, 1, 2, 2, 1, 3. And here we have the alkane, the drawing of the alkane. I am going to define the alkanes. The alkanes are saturated hydrocarbons because they are joined to another 4 carbon atoms in the chain. Here, for example, there are two in this carbon atom, 1 and 1, 4. The general formula is CnH2n plus 2, where n is the number of carbon atoms, and the names from the Greek and Latin. They are derived from these languages for the number of carbon atoms, and they use the suffix n.
Alkanes are unsaturated hydrocarbons that contain one or more double covalent bonds between carbon atoms in a chain. The simple alkane has two carbons atom double bonded to each other, and the general formula is CnH2n. Naming alkanes. Alkanes always have a double bond, and they're always going to end in this. I mean, this thing is the one that is going to indicate that it's an alkane. And well, to name alkanes with 4 or more carbons in the chain, it's necessary to specify the location of the double bond. And you always have to start from this point. This is going to be correct. But in the other example, this is going to be incorrect because they start from this point. The first thing we have to do is to count the carbons. In this example, there are 7 carbons, so we know that we are going to use the hept because the hept it means 7. How we know that this is an alkene? Because the double bond there is this that I'm going to color. To start counting the carbons, you have to start to the closest double bond. I mean, like 1, 2, 3, 4, 5, 6, and 7. You always have to start in the lowest number. In this case, it's going to be 2. And this is indicators that the double bond is between 2 and 3. So, because we have 7 carbons, that means that we are working with hep, as I said. And the double bond is in the carbon number 2. So this means that we're going to have hep 2. And because all the alkenes end with N, this is going to be a hep 2N. That means we have a chain of 7 carbons that has a double bond in their second.
The objective of this tutorial is to know what are hydrocarbons, their main classifications, what is and what does the UPAC, also what is alkanes, alkenes, and aromatics, and how to name these compounds with UPAC. Also, to draw structural formulas of these compounds. Here, I'm going to talk about alkenes. What are alkenes? Alkenes are unsaturated hydrocarbons that contain one or more triple bonds in a chain. According to the UPAC system, there are some rules that can help us to name these compounds. These are very similar to the alkanes ones, so that's why we have to differentiate in a good way the differences between them. The first step is the parent chain is the longest chain that contains a triple bond. What does that mean? It means that if you recognize a 10 carbon chain, but then you look at 5 carbon chain, but that chain has the double bond, you have to choose that. The second step is the position of the bond determines how the chain is numbered. That means that you have to number according to the place that is located the double bond, the lower number. Then is if you have more than one triple bond, you have to use a prefix. For example, D, tri, tetra, before the suffix y and e. This suffix is only used for alkenes. That means, for example, that if you have 2-ethyl, you have to put D-ethyl. If you have 3-methyl, you have to put 3-methyl, and so on. Then, alphabetically, you have to give the location and name of each substituent to the alkene. That means that if you have different substituents, you have to put the location, like the numbers, and then the name of each one. For example, 1-ethyl or 2-methyl. Here it is an example of an alkene, and I will show how to name it. First, you have to recognize the longest chain that contains the double bond. Here you can count 1, 2, 3, 4, and 5. And also here 1, 2, 3, 4, 5. So it is up to you, but I will choose the one that it is easier to recognize, that is the horizontal one. Then we have to number the chain, but that the double bond has the lowest possible number. For example, if we begin to count through the left, it will be 1, 2, 3, 4, 5. But if we begin to count through the right, it will be 1, 2, 3, 4, 5. That's why we will choose beginning to count through the right, so it will have the number 1. To recognize it, I will put it in a circle, so you'll recognize that it is the number 1. Then we have to locate the substituent. So it has 1, 2, 3, 4. It is in the location number 4. And as it is 1, the name is methyl. So it is 4-methyl. And finally, as it doesn't have prefixes, it will be alphabetical order. As it is 1, you have to put 4-methyl 1, locating the number of the double bond. As it has 1, 2, 3, 4, 5, the prefix is pent, so it will be pentyl. 4-methyl 1-pentyl. So here it is written the name of this compound, as we said before, 4-methyl 1-pentene. Now I will talk to you how to draw structural formulas of the alkenes. The first step is write the number of carbons in a chain containing the triple bond depending on the name that it has. Consider the location of the triple bond to draw it correctly. That means that if the name says butene or pentene, that means that you have 5 carbons or 6 carbons. So, depending on the name that it has, is the name of carbons that you will write. You have to consider that you have to draw the triple bonds, depending if there are 1 or more. The next step is begin to count with the indicated location of the triple bond and the substituents for putting the triple bond in the substituents as the name indicates. That means that you have to number all the carbons so it can matches with the name that it has. And finally, you have to put the substituents on the formula depending on the locations and the names or prefixes they have. This means that if your alkene has substituents, you have to put it on the correct location so it can matches with the name. And also, if there are 1 or more substituents, you put the correct prefix. Now I will explain one example of drawing the structural formula of alkenes. Here it is an example that says 3,3-dimethyl, 1-butene. We have to remember the rules that we said before. So the first rule was identify the name of this compound and the location of the triple bond, so we can write it correctly. As but is of 4 carbons, we will write 4 carbons and the triple bond in the first place. So it was CH, triple bond, then C, then bond, then CH2 bond, CH3. As we said, 1, 2, 3, 4, the triple bond in the first place. Now that we have written the 4 carbons of the butane, we have to count the carbons for locating correctly the substituents, because we have already wrote correctly the triple bond. So we count 1, 2, 3, as I said 3. So the location of the substituents will be here. D means the prefix of 2. Methyl is only 1 carbon, so we put the branches correctly. And recognize in which place it is. So we put CH3 and up again for having correctly this structural formula. So this compound is called 3,3-dimethyl, 1-butene, and this is the form that you have to write it. Hydrocarbons are an organic chemical compound that only contains carbon and hydrogen atoms. This is the simplest organic compound. This compound has the ability to form 4 bonds, and depending on this, it has a main classification depending on the number of bonds, that are alkanes that only form single bonds, alkanes that can form at least 1 double bond, alkenes that can form 1 less triple bond, and aromatics that had benzene and it has alternate single and double bonds.
The UPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization not affiliated with any government. The UPAC strives to advance chemistry, in part by setting global standards for names, symbols, and units. Nearly 1,200 chemists are involved in UPAC projects. 8 standing committees oversee the unit's work in chemistry. Why are naming rules important? The increasing large number of organic compounds identified with each passing day, together with the fact that many of these compounds are isomers of other compounds, requires that a systematic nomenclature system be developed. Just as each distinct compound has a unique molecular structure which can be designed by a structural formula, each compound must be given a characteristic and unique name. As organic chemistry grew and developed, many compounds were given tribal names which are not commonly used and recognized. Here are some common hydrocarbons: ethane, methane, cyclopropane, propane, methylpropane, butane, methyl cyclopropane, cyclobutane, methylbutane, pentane, cyclopentane, dimethylpropane, cyclohexane, hexane, cyclooctane, and octane.
Okay, there are 3 variations within the rules for naming aromatic hydrocarbons, because there's difference between when there is just one substituent, two substituents, and three or more substituents. For example, we've been naming an aromatic hydrocarbon of one substituent. We can use the IUPAC or just by numbers. But for example, with the IUPAC, according to it, we first identify the number of substituents, then we know that the name of the substituent will go along with benzene because their numbers are not necessary. Then you will identify the name of the substituent and you combine it with benzene. Example of naming aromatic hydrocarbons. There you have the structure and you see on one side a couple of carbons, and two carbons means that their prefix is ethyl. So as you know that you only need to add benzene to complete the name, you just put ethyl benzene, and there you have the name of the hydrocarbon. Rules for drawing aromatic hydrocarbons. The first thing to know about aromatic hydrocarbons structures is that the main characteristic is the form of a ring. Not all ring-shaped structures are aromatics, just like the case of cyclohexane, which is a compound that's not an aromatic hydrocarbons, but it is need to understand the ring structure of it, which is the stability equals the resonance, and this is a type of cyclic hydrocarbon. Example for drawing aromatic hydrocarbons. First you have the formula, which is 1,ethyl 2-methylbenzene. You know already that the structure of benzene it's a hexagon, so you just have that for sure. Then you see that there is ethyl and methyl, which correspondingly it's 2 and 1 carbons, so you just add the 3 carbons in different branches of the benzene structure.
I think that these kind of activities help us to know better how to solve the problems and also how to teach others about solving the problems. With this, I think that I learned how to explain someone else these topics, and I think that this acquired information helped me in so many ways, like not just in the school but in my daily life. Even if I don't notice, chemistry is present around us all the time.
For me, this activity was very practical and useful for others because it was making a video tutorial of how to name and draw structural formulas for hydrocarbons, and also it helps because it was very easy the way we explain it. So I think it will be kinda easier if you see this video, and we enjoy do it a lot.
As a conclusion, I find this topic very important because if we want
to grow on harder topics on chemistry, and especially in organic chemistry, we must learn the basics to know what we're working with the different types of hydrocarbons. So this is a great introduction.
We conclude, we'll conclude that we can ignore the importance of hydrocarbons in our daily life because with them we can do a lot of our daily activities. And carbon is one of the most important natural element, but not only for humans. Also, it's needed to perform our natural process. And through this work, we could realize the big importance of the carbon, and we develop a lot of different new skills.